Ian, sit down. Where's your seat, Ian? Alright, here we go. Exercise 3J. Now, just to recap a couple of things that you learnt prior. Will. In chapter 2, we talked about simultaneous equations of two lines. Now, if I gave you this, if I gave you y equals to 3x plus 1, and I give you y equals to 2x, I don't know, let's say plus 5, and I ask you, if you simultaneous equation this, and you solve for it, what are you solving for? When you solve for x and you solve for y in this case, what are you looking for? What were you doing again? Chapter 2. Okay, we can do substitution. So if you were to solve for x and y, you'd say since this is equal to y, you sub y here, and you get 2x plus 5 equals to 3x plus 1. And then you minus 2x on both sides, and you get x plus 1 minus 1 on both sides, x equals 4. Why do you need to know that? Okay, you put the 4 in. So if I put 4 into one of the equations, so if I put 4 in here, y equals to 3 times 4 plus 1, and I get now 12 plus 1 is 13. So what? What's the point of having 4 and 13? X equals 4, y equals 13. There's no point doing it if we don't know what it means. What does it mean? That's the point of intersection. Now the logic to this one is, when you have two straight lines and they cross one another, notice when the point of intersection, they both share the same coordinates. They both have the same point. And because they both have the same point, that makes sense why both the y coordinates are the same. If both the y coordinates are the same, that's why you can say 2x plus 5 must be the same as 3x plus 1. That's what you're saying there. You're saying at the point of intersection, x and y are the same. That's why the y values are the same. If the y values are the same, that's why you said this equation must be the same as that equation. So when you solve for x, all you're finding out is when x equals 4, that's what you found out. You just found out if y's are the same, what would x have to be? Once you know what x is, you can find out y. But what you just found out is the point of intersection. Now in a straight line, logically, how many times can a line intersect? If you have two straight lines, how many times can you intersect? Once. Once. So today's session, same concept. How many times can a line intersect a quadratic equation? So instead of a line and a line, you said once. What about a quadratic equation, which is parabolic, with a straight line? How many times can you cross?
Twice.
You can cross twice, or
Once.
or once,
Or
or not at all. And this is what it looks like. See, when you draw out, all you're doing is exactly what you just did with the straight lines back in chapter 2 or chapter 1. And in this case here, you can see a straight line will intersect either twice in a parabolic shape, or it intersects once, which we call the tangent. Okay, so if the line touches the curve once, we call that a tangent at one point, or it doesn't touch at all. Okay. Oh, we just call it the intersection. We're just saying that we're observing if you have a straight line with a quadratic equation, there's a chance that you can either cross twice, or once, or none. Okay, we don't give it a name, but there's a special name for the tangent, only because at the end of the year, you will be using tangent lines and next year for calculus. That's 2/3 of the course for next year. So that's something else, but at this point, you just need to understand when you cross once, we call it the tangent. Okay, when you touch once, they call the straight line the tangent. It could be at any angle. It could be at this line here. It touches once on that coordinate. Okay.
How do you know if this is intercept point?
Good, good. That's a very good question. That's what the whole exercise is about. Okay. If you were listening to what Ian asked, he said, "How do you know?" Listening. Ian said, "How do you know if the line crosses once or twice? Like, how do you know if it has two x-intercepts or not?" That's what we're doing today. Some of the questions you'll get where they don't have numbers, you have to figure out how do I get two x-intercepts, I mean not x-intercepts, two intersections, or one intersection, or no intersections. That's very similar to what you've been doing in exercise 3I. So unless you have done 3I, then you'll find that 3J will be a bit more difficult, okay? Just because there's more algebra. So I'm going to take you through just the basic steps, and then I'll do a question where you get to play around with the letters, where you get two intersections, one intersection, or no intersections, yeah? So let's have a look. Let's take this example, copy this example down, yeah, because I'm showing you the technique. You've got a straight line, so to find the points of intersection, you've got a straight line, and you've got a parabola, which is a quadratic equation. You've got x squared minus 8x plus 12, okay? Or parabola. Parabola. Parabola.
It's the new stranger.
It is the new strangest things. Okay, so, same thing what you did with two straight lines in chapter 2. See, the one example I gave you before, I said y equals 3x plus 1, and then 2x plus 4, or whatever it was. In this case now, you got y equals negative 2x plus 4, and you also have y equals now, instead of a straight line, you have x squared minus 8x plus 12. So the question is, how do you find the point of intersection again? It's the same technique that you did for chapter 2. At the point of intersection, we know they have to have the same x, y coordinates. Now conveniently, this tells me the y coordinate is equal to negative 2x plus 4. This tells me the y coordinate is x squared minus 8x plus 2. So, or 12, sorry, plus 12. And so if they have the same y coordinate at the intersection, that's when they have the same y coordinate. At the intersection, you can say this coordinate must equal to that coordinate. So y must equal to y. If y equals to y, then now you have negative x squared minus 8x plus 12 must be the same as negative 2x plus 4. Does that make sense? Because at the point of an intersection, they have the same x and y coordinates. Because they have the same x and y coordinate, you can say the y coordinates must be the same too. So think about it. I'm just saying, you have a parabola, you have a straight line. If they do intersect, okay, I'm not saying they do, I'm just saying if they do, they should have the same x and y coordinates. Now, if they have the same x and y coordinates, I can say, well, these two must be the same because they have the same y coordinates, right? So if they're the same, I can say that means x squared minus 8x plus 12 has to also be the same as negative 2x plus 4. This is where we're solving now. So let's solve the equation. We're saying at the point of intersection, they should have the same x and y's. So I'm saying, all right, well, if they have the same y's, why don't I just say that equals this then? Because they are the same y coordinates. This is a y coordinate, that's a y coordinate. I'm saying this equals to that, and this equals to this, and this equals to that. So what I'm doing? I'm just saying they're the same. Yeah? So that's what I did. I said quadratic is the same as your linear. Now your job is to solve for x. Now at this point, the only thing that you've learnt in chapter 3 to solve for x or quadratics is you always had one side equal to 0, then you can use null factor law. So your goal right now is to move everything across so that you get 0 on one side. So this is what I'm going to do. If I want to bring this to the other side, I'm going to do what? If it's minus 2x, you have to?
Add 2x.
Inverse, which is? Good. Add 2x. Okay, so I'm adding 2x on both sides. That now gives me x squared minus 8x plus 2x gives me negative 6x. I got a plus 12 equals to 4. And same thing again, if I want to bring the 4 across, what do I do?
Take it away.
Take it away. Take the 4 away. So I say minus 4, minus 4. And what you get now is 4 minus 4 is 0. And you end up with x squared minus 6x. 12 minus 4, which is? 8. It's a positive 8. Okay? Now I haven't solved anything yet. I've got x squared minus 6x plus 8 equals 0. This is like your exercise 3C. Using null factor law, but how to solve this? I've got 2x, that's a problem. Factorize it, 3b. See what I'm trying to say? Everything goes back to 3a to 3e. You have to be able to get the basics. Factorize this for me. X squared minus 6x plus 8. What do I get? Sydney. Ask someone else? I'll ask someone else. This is exercise 3b. Cross method. Yeah, that's the only method that we know so far. Yeah, so what would they be?
Minus 4 minus 2.
Good. minus 4 minus 2x and x. Now once I factorized it, I can solve for x now. So what does this tell me? What is x equal to? Good, 2 and 4. But what does this 2 and 4 tell me? Remember, it's not about learning how to solve it, that's the algebra. But my question is, what does that mean? You just figured out x equals 2, x equals 4, what is that? It's the 2 points. So I know, so answering your question in this case here, I didn't know until I got to this step. I didn't know if I had 2 x-intercepts, 1 x-intercept, or no x-intercepts at all. In this case I have 2. Because I have 2 points. I have when x equals 2, when x equals 4. Now I haven't got a coordinate yet, I only got the x coordinate. How do I find the y? Substitute x in 2 now. You've got these two equations here. You can find out y, you sub it into the linear, or sub into this one, doesn't matter. Both of them will give you the same because you said the y value is the same. Found x, sub it in. Now I put it into the linear because linear is easier. Why would you put it into quadratic when it makes it harder? Might as well put it into linear. So in my case here, y will have to equal 2 if x was 2, it's negative 4 plus 4, which is 0. So that's when x is 2, y is 0. That's my first coordinate. And the second coordinate is when x is 4, y will equal to negative 2 times 4 is negative 8. Negative 8 plus 4, which is negative 4. So that tells me 4, negative 4. These are my two coordinates. So answering the question, they said find the points of intersection. I just found them. 2, 0, 4, 4. Those are the points of intersection that I have. Okay? So I made up a sketch. I actually don't know if this is true. I'm just drawing the graph. Just so that you see, I either have 1 intersection, 2 intersections. In our case, we happen to have 2. How does that feel? Did that make sense? Yeah. Yeah? Good? Let's try the next one. Oh, yeah, sorry.
You know, like for the wire, right?
Yeah.
Like the intercept in a different way. They intercept. The intercept. What about the intercept? Like, you know, like what's it like? How do you know like that? Like this is like
Yeah. But how do I know that these two are equal? Is that what you're asking? Because you said that at the intersection they should be equal.
So they're both intercept.
No, we're guessing. We don't know. We're like pretending. If it is, then that should be the same. And if they're not, then you won't be able to solve it. But if they are, you should be able to solve it.
You're sure the one that they will come to it?
Yeah, let's try to find one. I'm not sure which ones don't work, but we can find one. Yeah? All right, next one. I want you to do it. Have a go at this one, and I'll go through the answers with you. But same thing. You got a parabola. Okay, you got your own quadratic here. And you've got a linear equation. I want you to do the same technique I just showed you from one of the notes that you just took. I want you to find the points of intersection now. You've got a quadratic and you've got a linear. Try to solve that. Okay, I'll give you, I reckon, 4 minutes and I'll do the solutions up there for you. I just have to do.
It's not part of the grad. I mean, technically, you should.
So wait,
there are questions in 3i.
Just I mean, I need to do 3
Yep.
X minus 8. But then you just calculate
I mean, that should be positive. What is it? I got x plus 8.
There we go.
Wait, so 6. So I got this 2 point, right? So how do I know if they intersect? So I got this 2 points.
Well, that must mean that it intersects at those 2 points. Because the very first assumption you made, the assumption you made is when they do, if they do intersect, they have to have the same coordinates. They gave you 1 and 3x. It looks like that, yeah? So when x is 3, what should y be?
Just sum it.
X is 3, what's the one?
So when x equals 3,
X is 3, take it down, right? So this is the point, when x is 3, y is 8. So if I give you another equation,
so it means like, for example, like if you start this equal, right? So what it means like,
but I'm pretty sure they were equal. The reason why is because you said you made a hypothesis. You said y is equal.
so there's no reason why this doesn't happen.
Yeah, what's the time?
So there's no reason.
There is a reason because we assume if they are the same, y should have the same y. So because they have the same y points, we're saying this y value must be the same as this y value. So that means this equation is the same as this equation. That's the assumption we made. And we don't know if that's true. Yeah.
I thought that was how
you already made the first assumption and you got an answer. You got an answer. It means unless you make a mistake here and this is wrong and this is correct and you have to change the
One day. It feels easy because it's algebra. You don't have to think too much, that's why. Yeah. All right, let's go through the answers. Here we go. So same thing again. If they do intersect, it's always about the if. We don't know if they intersect or not, but if they do, these y coordinates should be the same. At the point of intersection, they have the same y's and same x's. So if that's true, that means this y equals x squared minus 6x has to also be the same as 8 plus x because they have the same y value. So that's what I'm doing. I'm equating it. I'm saying x squared minus 6x should equal to 8 plus x. We don't know if that's true. We're just testing it. Yeah? So let's work it out. So from here, the only quadratic techniques we learnt is if you have the right-hand side or left-hand side equal to 0. So what I'm going to do here is I'm going to say, all right, well, I need to remove the 8. So opposite of plus 8, minus 8 on both sides. Good. Minus x on both sides as well. So this should give you, in the next line, you should have had x squared. Negative 6x minus x gives you minus 7x. You got a minus 8, and that should give you 0. Okay? Now from here, it's about factorizing. So exercise 3B, that's what we've been practicing in your quizzes. Good. Negative 8 and a positive 1. Whoops. And that now gives you x is equal to? What is x equal to? Exercise 3C. Good. Negative 1 and 8. Listening. Listening. So you got now x equals negative 1, x equals 8, but you have to remember, what does this mean, Seb?
Yeah.
Don't talk while I'm speaking. Thank you. Now that you've got x equals -1, x equals 8, then the question is, what does that mean? Because it's not about solving it. You have to understand what it means first. When you have x equals -1 and 8, that now satisfies the sort of assumption we made. We said that we assume that they're equal, meaning that they do intersect. In our case, we found out two answers for them to intersect, for them to have the same y coordinates. So what this implies is you have 2 points of intersection. Sometimes you might have one, sometimes you have none. But you just have to understand it's okay if you can't get an answer. If you don't get an answer, it just means you don't have any intersections. That's all it means. So don't get freaked out when you don't get an answer, or don't get freaked out if you only have one answer. It just means that for this line and this parabola, whether they actually even intersect at all, we don't know. We just made up the assumption. We just said, if they do intersect, this should equal to that. And we said, let's see if we can solve anything. And if we solved it, we're like, yes, apparently if I had -1 and 8, they should have those same y coordinates. If they have the same y coordinates, that means they're intersected. Yeah? Sometimes you might not find an answer. But you haven't finished the question, you need to find the points of intersection. So, sub it into any of the equations. X equals -1, I'd put it into linear, it's easier to solve. Wait, listening. 8 minus 1 is 7, and you got the other one as 8 minus 8, which is 0. So your 2 points of intersection is -1, 7, 8 and 0. All right, listening. Hands up. You got those 2 points of intersection, -1, 7, and 8, 0. But did I do the 8, 0? 8, 16. Yeah. Oh, sorry. I was testing you. Plus.
So like to get 2 points, right? When factorize, if you get 2x, it means like it's always 2 intercept point.
Yeah, you're right.
Always 2 intercept point.
If you factorize, then you get 2 x values, yeah.
It's 100% figures, right?
Yeah, at this point, yeah. Because you solved it.
Yeah, but if you have 2 points, right? Would there a chance if there's no intercept point? Is there a chance?
No.
How about 1?
No. Or unless they're two of the same ones. So if you have x minus 1 and x minus 1, then that's the same thing as saying x minus 1 squared.
You did right. You did right anything.
Didn't I? If you have x minus 1 and x minus 1, then the answer is just 1. True? Then there's only one x intercept. Yeah? Alright, next one. Okay, year 11s, find down. Will. I need you to copy this example down because now, so hopefully you've picked up on the method on what you were doing. Now the later questions, you'll start to have what we call parameters. So unless you understand what the question is doing, then you can answer it properly, right? So any questions after this is going to get difficult, but you have to know how to do the first part. So I taught you how to do the first part. I'm now teaching you, it says find the value of C. Okay, so you want to find C so that the straight line equation, Finn, straight line equation intersects with the parabola once or twice or 3 times. Now in our case, when it says tangent, it means once. Okay? So the question is, you don't want to sit there and trial and error C until you get one solution. See, we don't want to do that. We're trying to teach you a technique to be efficient. We want to solve it so that we know that it's only going to be one intersection. Okay, so this is different from what we did before. See, the difference is this equation, I gave you a number. I told you x, I told you a. There's -6x there, there's an x, but there's no parameters. What's the difference? In this equation, same techniques, but I'm now saying, what if I didn't tell you that number? You have to figure it out yourself now. You have to figure out how do I only get one intersection. I don't want 2, I only want 1. Okay? So, same drill again. If this is your linear equation, you got y equals to x plus c, that's a linear equation, straight line. You got y equals x squared minus x minus 12. Thank you. You got y equals x squared minus x minus 12, and you're asking the same question. You're saying now, how many times do they intersect? In our case, if they do intersect, it's always the word if. If they do intersect, they should have the same y coordinates. If they have the same y coordinates, x plus c should be the same as x squared minus x minus 12. Okay, this is where it's key. So if I go to the next step, this is what we're saying. We're saying if they do intersect, then x plus c should equal to x squared minus x minus 12. Now this looks different to what you were doing before just because you have a c in there. But it's the same technique. See, if I minus x on both sides, so minus x, that cancels out. I get c is equal to x squared minus 2x minus 12. Okay, I'm just minusing x on both sides. Nothing scary, yeah? Then I say, subtract c on both sides, and this is what I'm going to get. 0 equals to x squared minus 2x minus 12 minus c. Anyone confused so far? All I'm doing is just put a c in. If I had changed that to a 3, you would have said subtract 3 on both sides, subtract x on both sides, yeah? That's an x plus c, so I said if that's an x, subtract x on both sides. That's a c plus c, so I said minus c on both sides. Same thing, whatever you did before, yeah? It's just like a letter c, okay? Now you get up to this step here. This is not nice because we don't know how to factorize it, true? This is a problem because I don't know what the factors of negative 12 minus c is. Unlike before, you were able to factorize this and then solve. So what do you do now? See, how do you do this problem when you know you need to have one intersection? What's the key? What's the one thing that we know, Nikita?
When it was just it's a tangent, right? So tangent, that means the discriminant equal to 0.
Yeah. Why is discriminant equal to 0 again? Remember I said the only way, or in exercise 3I, the only way for you to get one x-intercept was if the discriminant equal to 0. So here, you can't factorize it, but what you can do is find the discriminant. See, from the exercise 3I, you can go to this and say, all right, well, I know for it to have one x-intercept, or one solution, it has to have discriminant equal to 0. So in my case, what was the discriminant again? What's the formula for discriminant? Will? Okay, next one, Lauren.
It's the one in the square root, but I don't remember the letters.
Yeah, the one in the square root. What was that again? B squared minus 4ac. Fantastic. Okay, this is your discriminant formula. Now, if you look at your equation, here, what's my a, b, and c? What's my a, b, and c from that equation? What's a equal to?
1.
1, because it's the number in front of x squared, which is 1. See, the number in front of x squared is 1. We don't write it, but it's 1x squared. What's the number in front of x?
2. Negative 2.
Negative 2. See, that's my x there, b. So negative 2. And my c is negative 12 minus c.
Wait, what was in that 1? Okay.
Yeah, that's why I said.
I thought it was
No, I only said this equation. I said you got to find the discriminant of this. So you got a equals 1, b equals negative 2, and c equals negative 12 minus c. Now, answer the question b squared, you got negative 2 squared minus 4 times a times c. Okay, this is really much the same as exercise 3I. So if you watch my videos, I had like 4 videos on how to do exercise 3I. Yeah, it's the same drill. So here we go. You got 4, expand the brackets, that becomes negative 4 times negative 12. You got plus 48. Negative 4 times negative c, that gives you plus 4c. This gives you a total of 52 plus 4c equals the discriminant. Okay, so all I'm doing, so far all I'm doing is I'm working for the discriminant. B squared minus 4ac, I put in b, I put in a, I put in c, that's all I did. Then you got negative 4 times 1 is negative 4, negative 4 times negative 12 is 48, negative 4 times negative c is positive 4c. Yeah? I'm just going through those. Now, we got the discriminant, but we said the only way to get one intercept or one solution was if the discriminant equals to 0. So if this equals to 0, what should C be? That's all you're asking. You're saying if the discriminant is meant to be 0, then what would 52 plus 4c, what would c have to be to get that 0? You're solving for it now. Minus 52 on both sides. Whoops. Is 4c, and therefore c, 52 divided by 4, which is?
13.
Negative 13. So what does that mean? You just figured out c, because that's what the question asked. The question said, find the value of c such that this straight line has one intersection. So if you actually try it out now, if you put in x minus 13, and you want to see whether it intersects once or not, test it. And you'll see it crosses once. There's no guess and check now. You're just solving for it. But you see the technique, all I did different from what you've been doing before was up to this step. We couldn't factorize. I don't know how to factorize, but I do know that if I only want one answer, I can use the discriminant. That's all I did. A, B, C. Using discriminant formula, b squared minus 4ac. I went through it and I said the only way to get one intercept is if it was equal to 0. I put 0 in. C equals negative 13.
Wait, if a discriminant equal to negative, so it means that non-intercept, right?
Yes. And that's how you answer the other questions. That's a very good point on what Ian just asked. He said, if you have discriminant less than 0, okay, that means there's no x-intercept. That's true. And if you have no x-intercepts, that means there is no intersection. Because you can't find any x coordinates. If you can't find any x, then of course there's no intersection. If you can find two x coordinates, if you get two solutions, if you get two x coordinates, it means it intersects twice. If you get only one x-intercept, then of course you only cross once. Okay, so that's what the discriminant is working for. It's telling you how many answers you can get from this line. That's exercise 3I. And if you're struggling with 3I, I already did questions 5 all the way to 12. Yeah, 5, 6, 7, 8, 9, 10, 11, 12. I describe each one of those and I've done videos for that. So it's up to you whether you watch that or not. And I'm not staying behind, I'm not holding back on making sure you're all on the same page. I'm moving forward. Because we're so way behind, I'm now moving forward. The video's up there, it's on you, whether you're going to watch it or not. Today's 3J, second half of the session is 3K. If you're not following, that's on you. Video is up there, this video is being recorded. I'm doing the solutions here with you. You just got to work with me. Yeah? Got to pick up your game. Watch the videos, work through with it. And like I said, I've got support classes on Friday. So if after school, if any of this is confusing, you've got to come. You've got to be proactive with your learning. I'm here to help, but I can't hold your hand all the way. It's up to a certain point, it's on you. Yeah? All right, so that's exercise 3J there. Any questions on how do you feel about that? Does that feel a bit better? Okay, so if you're not sure, you can start off with this type of questions. Find out x and y's using your algebra. These are the questions that you want to be able to work to, because it ties everything together. Discriminants, sketching the graph, factorizing, solving. That's what 3J is about. Yeah? All right. Now, just before I let you guys practice these questions, if you have your calculator, grab it out. I just want to show you how you can solve on your calculator to make sure that you know you're doing it right. Okay? Let's grab out your calculators. Let's go.
Go back.
Go back?
That's a lot of tabs.
Yeah, I have a lot of tabs.
Another desktop.
That's true. I don't normally do that.
Windows.
You can do that.
Windows 8 features.
I think it was like this. There we go.
That's the only good thing from Windows 8 is new desktops.
I don't know how to go back. There you go.
I often use multiple desktops to hide some. Yeah, exactly. I'm not.
Grab out your calculators. If you have a calculator, grab them out. We good? Alright. Alright, year 11s, watch this. Eyes and ears towards the board. Do you have a calculator?
Not battery, but.
Well then, just pay attention then. Here we go. If I want to find the intersection of x squared minus 6x and y equals to 8 plus x, there's two ways to do this. You can do it algebraically on your calculator, or you can sketch it on a graph, right? Now, this is how I do it. I always define first, so if you never use the calculator, menu 1 is define. Okay, define is just to, instead of retyping the equation over and over, I use define. Now instead of using y's, you're going to eventually have to learn to use f of x. And I'll show you why, okay? So let's go f of x. So how you do it, you type in f, you got your letter f, open bracket, and then close bracket, yeah? So f, open bracket, x, close brackets. Now this is equal to, now the first equation that you had was x squared minus 6x. So I'm going to write it down. X squared minus 6 times x. Once you're done, press enter. What that does is every time you type f of x, it will know it is x squared minus 6x, so you don't have to retype them. Yeah?
What is for?
I'm showing you how to solve on the calculator. Second equation.
What the hell?
Just pay attention to you. Yeah? I've got a recording. You can watch it again. Here we go. F of x equals x squared minus 6x. I'm just trying to solve what we did before. This is what we did before. We had x squared minus 6x. Now the second equation is x plus x. Now I'm calling that equation a different letter. I'm calling it g. You can call it h, you can call it p, you can call it whatever you want. Now in our case it was 8 plus x. I defined it. Okay? The nice thing about this is once you define it, you can do a lot of things. Here, I'll show you what I mean. See, if I go into control, doc, and you add a graph, you can, instead of typing the equation the second time, you can really just type now f of x. And it sketches it for you. See what I mean? Instead of typing the equation for the second one again, I can type g of x. And it comes up. Now from this graph, you see you can analyze it just by finding those 2 points of intersections there. I can show you how to do that on a calculator, but I'm going to show you how to do it algebraically first, okay? So you can see there are 2 points of intersection there. And all I typed was f of x, and I typed g of x. That saves you time from repeating the same equations, because in year 12, the equations will get really large. There's a lot of fractions and decimals. You don't want to type that over and over. You might make a mistake. That's why I encourage you to use define. Okay, define allows you to do that. Now, second thing is if you want to solve for it, how do you solve? Same thing in your menu. If you go to menu, algebra, because that's what you're working with, right? Algebra, you're trying to solve. You want to solve the equation, because that's what you were doing manually before. So you go menu 3, 1. Now you got to solve. Instead of typing the equation, see, normally you would do this. You'd say x squared minus 6x, minus 6x times x equals to 8 plus x. That's what you did. Okay, remember this page? That's exactly what you did here. You said, where is it again? X squared minus 6x equals to 8 plus x. Instead of doing that, it takes too long to type. What you can actually do now is you can just say f of x equals to g of x. See, I want you to solve for the first equation to equal to the second equation. But what are you solving for? In our case, we are solving for x. So how do you do that? You put a comma, put an x. So you get your answers, -1, 8. And those are exact answers we got over here, -1, 8. Okay, so it gives you that opportunity to get -1 and 8 without doing the algebra. I'm just getting you to so that you can check it, yeah? Now you got -1, 8, what do you need? You need the y coordinates. So you got the x coordinates, how do you find the y coordinates? You told me before. Yeah. Now what you don't want to do is type the equation again and replace it with -1 or replace it with -1. It takes too long. So the reason why I asked you to define is because you can do this now. You can say f of -1. See, if you do that, they tell you it's 7. F of 8. So what that means when you say f of -1, this just means take -1, sub it into the first equation. When you say f of 8, it just means take x equals 8, sub it into the first equation. That's why it's important that if you do the first 2 steps, it's so much easier to do everything afterwards. See, I did it all. I got when x equals -1, y 7. That's my first coordinate. My second coordinate, when x equals 8, y equals 16. That is much quicker calculator-wise. Okay, so at the mid-year exam, when you're doing your exams, learn to do this. You can do it all by hand, I know you can. But by that point, you'll take too long to do it. You have to learn how to use your calculator as well, especially for multiple choice questions. Okay, so if you have a calculator, learn to practice those 2 skills, define and solve. That's for the calculator section. Let's say you didn't want to use the calculator section. Let's say you wanted to do it through a graph. So you got up to this step, you define f of x, you define g of x. How do you find points of intersection Is that a no? Points of intersection, same thing. Menu. In our case here, we want to analyze the graphs. So number 6, and conveniently, there's the word intersection there. So if you go to 4, you'll get the same answers. If we go from the left-hand side, so we know the intersection is right here. You just got to choose a boundary. So if this is where the intersection is, just choose the left-hand side and right-hand side, and I'll tell you where the intersection is. So watch. I'm going to choose the left-hand side. I'm going to say, choose this left. So I click it once, then I drag my mouse across it, and then I click it twice. And it tells me the point of intersection on that side is -1,7. So if I want to do it again, I can do it again. Menu, analyze, which is number 6, intersection. So this is the left-hand side, and the right-hand side, I move it to the right-hand side. And I get 8/16. So there's 2 ways to do it. So I just showed you how to do it algebraically. I've shown you how to do it in the calculator section only. Now I'm showing it to you how to do it graphically as well. So you can do it on graphs by analyze. You get the same 2 points. 8/16, -1,7. You guys did exactly the same things just now. You did it manually there. You did it in this page. And they're all the same thing. -1,7, 8/16, or you can do it graphically. Okay? So that's just for 3J. I just want you to work with that. Working out how to find two intersections, 1 intersection, and no intersections. Okay? I know the later questions are going to be a bit tricky if you haven't done 3I, but I'll do the videos for that. Yeah, so for 3J, I'll be doing the questions that are hard. You can watch those again. But my point is, you just got to work with me. You got to keep moving forward. Otherwise, you're stuck in 3A to 3F. If you haven't done those skills, you find all of this very difficult. That's why I was trying to say from chapter 2, I told you and I warned you that it's going to be hard if you don't pick up your game. Yeah? So the SAC is going to be all on all these ideas. You have to be able to factorize, have to be able to solve, have to be able to sketch. Without any of that, you can't do the next chapter, which is chapter 6. Okay? So you just got to learn these skills. You have to learn it if you want to do methods throughout. Okay?
Just want to throws. Oh, I guess without, why is it 2 from 6 to 12? I don't care about if it had a graph or not. You just write the, I know they do like 8 plus x equals x squared or 6x minus 6x into the calculator. Instead of writing,
you can totally do that. Absolutely. I was just giving you efficient ways to work with them. But you're right. You can absolutely not have to go through that. You could have just gone through. In this case here, you could have went solve, and you could have typed in x squared minus 6x equals to 8 plus x, and you got to tell what to solve for. So you do comma x. That's what you're solving for, and it should be the same. You get -1, 8. Yeah, so you can totally do it that way. I'm just encouraging to use define for later questions. Okay? All right, I'm going to leave that there. You guys can have about 15, 20 minutes practicing 3J or 3I, but I want you to work on your algebraic skills. You have to be able to do simultaneous equations of the quadratic and the linear equation. Yeah? Any other later questions that you find hard with a parameter, I will do videos on that to make sure you get it. Okay? But there we go. I'm going to pause the video.